If you're doing something else and you're not listening, don't blame me later.
This is so tilted though.
What?
It's so tilted.
It's what?
Tilted.
Super tilted. Okay.
Because I don't want us moving it around when I move there. Okay, but you can use that spot, so I just turn the ball.
Yeah, maybe push it more over here later.
Yeah.
Okay, yeah, already.
Ready?
Yeah.
Please pay attention, everyone. I thought I break these types of functions down to the class to avoid any confusion later. In your textbook, the only thing we have is one-on-one and many-to-one. I can't blame them because some of these definitions you don't need at this stage. But it might be more helpful to some of you, especially those in HR class. So I thought, okay, why not discuss it? Types of function. The basic one we're going to talk about today are these three especially. The injective function, the surjective function, and the bijective function. And they're kind of related. The reason I'm mentioning this is because the next thing we want to do is inverse of a function. When is a function invertible? When can we say the inverse exists or can be found? If the inverse cannot be found due to the class of the function that it is, what can we do if necessary? Okay? Some of these details, like I said, you don't need it in SL class. Even HR class, maybe not. But imagine you are working on a problem and the question is not directly find the inverse of this. The question is more of making you think about properties of function. You really want to understand some of these basic ideas. Okay? Now, so I start with the injective function. If you see one-to-one online or in your textbook, they're talking about the injective function. Or you just see, oh, this function f is an injection. It simply means it's an injective function. Okay? This is, as the name implies, one-to-one. Oh, that reminds me. The idea of domain and codomain, usually we use it together, particularly at this stage. They are not the same thing. So I thought I'd show you in a picture what you've been looking for all along, what you call the range, is this group. But the entire set is your codomain. So there are some elements in the codomain that are not necessarily in the range of a function. Do you understand that? So we need to first get that. Again, what you've been finding all along, find the domain and range, remember?
Yeah.
That's not the entire codomain. Your range could be exactly the same as the codomain. Maybe we call the codomain D prime, for example. And sometimes it could just be a proper subset. Sometimes it could just be exactly the same. But I didn't go into those details because we don't need them. Quickly, please.
Can you explain what a codomain is again?
Okay. The codomain is the set of, a bigger set where your results can be found. Most of the time, your codomain could be the set R.
Oh.
But it doesn't mean every number in R can be obtained from your calculation. I'll give you an example. Y equals, say, let's say x squared. Okay? This, for example. Your domain is every member of R, isn't it?
Yeah.
Every member of R is qualified, isn't it? Your codomain is also a real number. But not every real number can be produced. As a matter of fact, the negative cannot be produced. So in this case, our range is just a subset of R. Do you understand?
Yes.
So among the entire R, only the positive one can be obtained.
Oh.
then that is your range. That is the set of the images. Okay? These images are part of a larger set. The only thing is that the other members do not have a representation from the domain. Do you understand? They are the ones that are left out in my mapping diagram. So Y is my codomain, but just this set Y1, Y2 is my range. But again, you don't need to worry too much. In IB, some of these things are not really considered. Maybe in the university, when you start doing real analysis, for those of you that have any business with that, then you can talk about it extensively. Okay? That's the reason we are not really focusing on it. But the reason I mentioned that is because it's part of the explanation here, and I want you to have an idea. Okay? Now, if you have a one-to-one, it means for every element here, there is only one element qualified for you to get the outcome. That kind of function is a one-to-one function. It means, oh, one person, so just one-to-one partnership in the class. It means for every member, there is a partner. You cannot have, oh, Ansin and Alex are having him as their partner on the table. No, that's not one-to-one. That's many to one. Am I making sense?
Yeah.
When you have something like that, it's not a one-to-one function. Your function x cubed is one-to-one. How do you know a function is one-to-one? This is the easiest way for your level. Remember the vertical line test?
Yeah.
You can also do the horizontal line test.
Yeah.
Which means when you slide on the y-axis, you can only touch at a point. So if you look at my y is equal to x squared function, which is this, does it pass the vertical line test?
No. Yes.
Please think before you talk and calm down. Does it pass the vertical line test?
Yeah.
Yes.
But does it pass the horizontal line test?
No.
So this is not a one-to-one function, even though it's a function. Because my vertical line test will go this way, right? It can only touch at a point. So yes, it's a function. Then remember, that is the criteria that distinguish between what and what?
A function.
A relation and a function. Thank you. But look at the horizontal line test, it does not. The reason is because for -2 and 2, they get the same value, which is what?
Why?
4. Thank you.
That's a problem.
I'm talking about x squared. Answer.
Oh.
Does it make sense? So this is like, oh, many map to 1. So that's not a one-to-one function. But if you look at the graph of x cubed, it goes like this. Does it pass the vertical line test?
Yeah.
Yes.
What about the horizontal line test?
Yes.
So this is a one-to-one function. Okay? So if you take O, let's say I have an element x, there is only one f of x on the other side of it. You cannot, if you pick another element x2, you can never get the same f of x1 again. Are you getting what I'm saying now?
Yeah.
If you pick two different elements, there will be two different images on the other side. Then that is a one-to-one function. Does that make sense, please?
Yeah.
Yes.
Now let's go to the surjective function. A surjective function does not leave any element in the codomain behind. Look. This is surjective, but this is not, because this guy is left behind.
Oh.
Does it make sense? Again, surjectivity has nothing to do with injectivity. So it's possible it is surjective, but not injective. It is possible it is surjective and it is injective. They are not related. These two properties are independent. Am I making sense? So if every element in Y has a pre-image in X, which means nothing is left behind, it's possible there are two things being mapped to it. Nobody cares. As long as every member here can say, oh, I know someone on the other side. It is possible that Joey and I are in Y, and we are claiming to have known Ansin. Or, okay, the other way around, sorry. It's possible Joey is claiming to know two people here. As long as Joey is not left behind, it's fine. So that is what I'm trying to demonstrate here. So if you have all of them here considered, again, you don't need to think too much about it. I just need you to understand the basic idea behind it. Okay? So this is surjective, but this is not surjective. Because there is at least one element in the codomain which does not have a pre-image in the domain. Okay? Now, let's take, you will probably see some of these things in maybe a rational function, where something has to be removed. Do you understand? Because they will always be, oh no, we can never get this value. Is that not? And that value is part of the entire R, for example. Am I making sense? Now, bijective. Bi has to do with two. It means it does satisfy these two properties. If it satisfies these two properties, it is a bijection or a bijective function. You're sleeping, you want me to kick you out? Please. I know you understand, but don't sleep.
I understand.
Yeah, of course, of course. Does it make sense? So to be a bijection, you must check it must be injective and it must be a surjective function. HR students especially, please take notes of all this. So look at this. Is this one-to-one?
Yes.
Yes.
Is every element here taken care of?
Yes.
Yes.
Then this is a bijection.
So is the first one also bijection?
You tell me.
Yes, right.
Is the first one also a bijection?
Yeah.
Are you sure?
Yes.
Ryan, do you think this is a bijection? What makes it a bijection? King. Two properties. What makes a function a bijection? Speak louder, sir. It must be one-to-one and it must be surjective. Okay, nice try. You can call it onto as well. It must be one-to-one, it must be surjective. It must be injective and surjective. Injective is the one-to-one. Surjective means every element in the codomain has a pre-image on the other side. Okay? So, that's why I said if every element in, for every element in Y, there is at least one element in X, because it's possible there are two elements in X. Okay? Now, again, everyone, is this a bijection?
Yeah.
You just have to check. Is it one-to-one?
Yeah.
Yeah.
Yes. Now, is everything here taken care of?
Yes.
Then it's a bijection. Does it make sense? Now, is this a bijection?
No.
Is it injective function?
Yes.
But is it a surjective function?
No.
Why is that melody? Speak louder, please.
Because Y4 doesn't have a pre.
Y4 does not have a pre-image. Please give her a round of applause, please. Y4 does not have a pre-image. Okay? Now let's look at this. Carolina, is this a bijection?
No.
No. Why?
Because
Speak louder, please, and fast.
X3 and X2 have the same one.
Say that again.
Or is that
Shh, you're not Carolina, so shush.
okay? Because both two X's have the same one.
Is this a bijection?
This is not a bijection
Because
because Y2 has two pre-images, so it's not one-to-one.
it's not one. Just say it is not one-to-one. That's enough. The two criteria is must be injective and surjective, right? But it is not a bijection because it's not injective. Period. That's all. If you want to expatiate further, then you can say, oh, it is not one-to-one. Oh, because Y2 has two pre-images, and that disqualifies it from being a one-to-one. Okay? So this is, but is it surjective?
Yeah.
Subjective, yes, it is.
So this is a non-injective surjective function. Do you agree? What about this one? Raise your hand if you want to try this. Not you. You've spoken today already. Not Carolina also. Let's try. Any other person. Not you as well, of course. How about Marco? Is it bijection?
It's not.
Why?
It's not one-to-one.
It's not one-to-one. Of course it's not one-to-one. Another reason why it is not a bijection, Carolina.
Because it has a y value.
You're still not listening.
Because it doesn't follow the subjective rule.
It is not subjective. You like to explain shit too much. Just go straight to the point. It is also not subjective. Okay? It's like saying, oh, because that person belongs to the set of boys. Just say it is a boy, period. Does that make sense? So these are the major. Now, if you check your textbook, you might see something like many to one. This is an example of many to one. Okay? So, please let's take notes quickly. Again, any function that is a bijection is invertible. That's the whole concept. Yes, sir.
Then what's the third one called? Is there a name for it?
No, it's just simply a non-injective. I'm just giving you an example of a function that are not bijections.
Oh, okay.
Okay? It's not bijection because it's not injective.
Yeah, I know.
Yeah, that's what I mean. So this is a, the H is non-injective, but surjective. Surjective, not about not the right thing. So here W is neither injective nor subjective function. Let's see. Did I put this X somewhere? I didn't miss that. So again, I don't think it's necessary to put the many to one. Does everybody understand what they mean by many to one?
Yeah.
Yes.
Okay, so these are the three major ones I need you to focus on. So now, we can discuss inverse of a function. It's okay, ma'am. So basically, I saw Ansen yesterday. I called her, she was not. She can't hear me. I'm wondering what is
Maybe
she
she's ignoring
doing?
you.
Then I'm like, okay, maybe she's singing again. Maybe when she's singing, she's lost in the, she's in that lovely realm, beautiful, thinking about the song and the body. Then she said she was talking to a friend. Well, I decided not to investigate further. I didn't know that friend is. Of course, you don't know. Maybe it's our friend that people stare at on the computer. Who knows?
It's a boy or a girl?
I never said that.
I'm so hungry.
It's a fear.
It's a boy or a girl?
I never said that, Miss Ada. Miss Joey. Miss Joey.
Wait, what?
Yes.
I love it.
It's really good.
Say fat
What's that?
value.
Chinese It's a Chinese traditional sauce.
Oh, okay. I'll leave it wait now. I'm done with this.
You dropped the baby.
Alex, 不要嗰個。
You dropped it.
好。
Oh, I'm allergic. I'll die.
Really? I won't die. Can I have one?
Wait, Benji, what are you allergic to?
Wow.
If you cook
So if I
them.
cook them, it's
Please,
fine.
quickly, thank you. And this point is very important for you. We're going to be using it a lot. If f of x is equal to y, then just like sine and sine inverse, okay? Then x will be f inverse of y, something like that. This point is very important. I'm sure this is not new to some of us. I taught you guys in IGCSE, and I'm repeating it again. Just pretend that some people don't know it, so I'm doing it again. That's fine. So this is what inverse function is. The homework I'm going to give you, I think the old school hands at 10:45 tomorrow. So we are not going to be meeting, which means technically this is the last class before the Chinese New Year break. So I'll be giving you an investigative homework to find out for me some properties of inverse function. Some of them are linked to composites, composition of function. I think I put in about 4 to 5 questions in that 2-page worksheet. And they are due on Monday. I know we don't have class on Monday, but submit on Monday, please. If you submit later than Monday, I might take off some points. Anyways, to find inverse of a function, you follow the following steps. I'm repeating this for those that were not my student last year, or those that were not in SON last year. If you were my student, this is the same step I gave you last year. To find f inverse from f, the first step, let y be f of x. Change y to f of x. The second step is make x the subject of the formula. We'll discuss that in a bit. Once we make x the subject of the formula, then we replace x with f inverse of y. Where does that come from? From here. I would say because or since x is equal to f inverse of y. I'll show you. And finally, we just change the variable. Change the variable back to x. Change the variable to x. These are the summary. This is the summary of what to do. Please pay attention. Let's pick a function. Miss Joey, I need your attention as well. Sorry, Miss Rita. Let's pick a function. Example. Find the inverse. So the function may be g, so I just say find the inverse of y equals, no, f of x, sorry. F of x equals maybe, I don't want to start too easy. Okay. Please pay attention. Elsie, I'm sure you are part of the 18 elements in this set. If I give an instruction you are not obeying, sometimes I might throw you out because you seem to be above the law sometimes. Find the inverse of this function. The first thing you need to do, step 1, replace f of x with y. So you write, let y be f of x. Immediately you write this, for my solution, especially, this is IB, this is not IGCSE. If y is equal to f of x, it implies that f inverse of y from here. This is like saying sine x is equal to 0.5. What is the next thing you write? X equals to sine inverse of
0.5.
That's exactly what we're saying. If f of x is y, if you must drop this x, you take the inverse of the other side. It's just common sense, right? The same thing happens here. And that is what inverse means. Oh, I forgot to draw the mapping diagram. What happens here is this. it takes this element back. The inverse is what takes it back. So it takes y2 back to y3 back to x3. It takes y2 back to x2. Does that make sense? The reason it must be both injective and surjective is that if it is not, let's look at this. If it is not, let's say this one. We say this is not invertible, right? When it's taken, this is left behind. Right?
Yeah.
And in a function, you shouldn't have anything behind here. Am I making sense? If you also look at this, oh, you go like that. What's going on? Y is taken back to two things. Just like this. Taken back. This one failed the test already. Like this one, sorry. Oh, it's been taken back to two things. It failed the vertical line test automatically. So when coming back, it is not a function anymore. But to be a function in both ways, these two properties must be observed. So the reverse of that arrow, that mapping rule, is what we call the inverse function. Thank you, Joey, for that. Now, if y is equal to this, immediately, everybody, let's write. F inverse of y is equal to x. This is my left side, this is my right side. If I need to isolate x here, then this must take the inverse of the y. Does it make sense? We're going to come back to this step in the last line. Now, from your left y is be f of x. This is y now. Okay? So y is f of x means, oh, y is equal to 2x minus 1. Can you see?
Yeah.
This is this. F of x is this. Okay? Then we make x the subject. Ryan, do you understand? Do you understand, yes or no, please?
Yes.
Do you understand? Do you understand? Good. Make x the subject means rewrite the equation so that x stands alone. Okay? So y plus 1 is equal to 2x, correct?
Yes.
So I can say x is equal to y plus 1 divided by
2.
But we already said that x is f inverse of y. So I can replace it here. X is f inverse of y. Y plus 1 divided by 2. Just change the variable, which means f inverse of x is simply x plus 1 divided by 2. Why do we just change the variable for no reason? Because y is just something. It's like saying f inverse of something is equal to something plus 1 divided by 2. Who cares what that something is? Okay? If we really care what that something is and we are afraid of changing it, then when somebody asks you to find f inverse of 2, you should be able to tell them, sorry, I can't change it to 2 because it must always be x, nothing more. Right? But when you are asked to calculate f inverse of 0, you just replace x to 0. When you're asked to calculate f inverse of 2, you replace x to 2 because what this is doing is just creating a space. Okay? It's like a chair. Oh, put a chair there for maybe the next student Mr. Daniel is having a meeting with.